Imaginary numbers. What an exciting algebra concept. In what contexts could an imaginary number occur? What is an imaginary number? These are questions we'll be asking today. I have excellent news. Here are a bunch of people that you are now going to be smarter than. This guy is Socrates. This guy is Plato. These guys had no clue about imaginary numbers. This guy, Al-Khwarizmi, the inventor of algebra, he had no idea about imaginary numbers. This 6-year-old doesn't even know what numbers are. You are going to be smarter than all of these people at the end of today because imaginary numbers are a relatively recent invention. And when I say relatively recent, I mean about 350 years ago. They were discovered. But the point is, after all of these guys, not this guy, he's just dumb because he's only 6. Example 1. What does this have to do with imaginary numbers? You'll see. Let's solve this equation. I need to isolate the y squared term. So let's start doing that. I'm doing reverse PEMDAS. I'm subtracting 9 from both sides. That'll give me negative 4y squared equals 64. Let's divide through by negative 4. So y squared would equal negative 16. And let's take the square roots to cancel out the square. Now, here's the issue. If you put square root of negative 16 into your calculator, you will see an error. And the reason is this. If I tried to square some number to get to negative 16, let's think about what that could look like. If I try to square 4, well, that's positive 16. If I try to square negative 4, that would still be positive 16 because a negative times a negative is a positive. So what could I square that gives me negative 16? And the answer is nothing. You would have to make up an imaginary number in order to square to negative 16. And that's exactly what mathematicians did. They said, hey, there is no way to square to a negative number. So if I have the square root of a negative number, that just doesn't make sense. It's imaginary. So the square root of negative 1 is I. So here's how you're going to solve problems with it. When I take the square root of both sides, I have y on the left. I'm going to have plus or minus something. We're going to break up root negative 16 into the square root of negative 1 times 16, which is the square root of negative 1 times the square root of 16. I know what the square root of 16 is. It's 4. Now I know that the square root of negative 1 is defined to be I, the imaginary number. And so my answer is plus or minus 4i. Weird. So what is an imaginary number? I, the imaginary number, is the square root of negative 1. It's imaginary because you can't actually take the square root of negative 1. But there are some interesting other properties that I want you to know about imaginary numbers. Let's think about what I squared would be. This starts to get a little bit weird. So let's think about what would happen if I squared I. I know that I is the square root of negative 1, right? What happens if I square that? Isn't the square of a square root, aren't those inverse operations? Don't they cancel out? So this square root and this square, they cancel, leaving me with just negative 1. So bizarrely, because when I square the square root of negative 1, I get negative 1, it turns out that I squared is negative 1. Weird. So I squared is negative 1. Interesting. And we're going to stop with these properties right now. There are some other cool ones, but these are the ones you absolutely have to know. I is the square root of negative 1. I squared is negative 1. Let's move on and do some more examples that you'll see. First of all, let's solve this equation. Okay, so I have a p squared over here. I have a p squared over here. Let's combine some like terms. If I add 9p squared to both sides of the equation, that'll give me 12p squared on this side, cancel on this side. Let's also subtract 7 from both sides. That will give me negative 3. Okay, I can divide through by 12. that would be p squared equals -1/4, like if I reduced that fraction. Now we're taking the square root. So p is going to equal, remember it's a plus or minus because every time I take the square root it could be a positive answer or a negative answer. And I'm dealing here with, let's put the negative on top of the fraction. That might be easiest because what's the square root of -1? Oh yeah, the square root of -1 is I. On the bottom, what's the square root of 4? Well, 2. So this problem, p equals plus or minus I over 2. Interesting. Here's another example you might see. Both of these things that you see in parentheses here are known as complex numbers. This looks especially like a mustache, which is fun. Anyway, both of these things are complex numbers. The reason they are complex numbers is, much like a young girl's changing emotions, they both have a real part without an imaginary number and an imaginary part. So they're complex because they have two different parts. So in order to subtract these two, it is as simple as combining like terms. Look, I should probably distribute this negative in. Then I have 8 plus 20i plus 8 minus 12i. I've just distributed the negative in. And at this point, I can just combine like terms, just as if I was a variable. 20i minus 12i is 8i. 8 plus 8 is 16, and so my complex number, my combined sort of complex number, simplified, is 16 plus 8i. This is still complex because there's a real part and there's an imaginary part, but it's in standard form because there's just one of each. Let's look at one more example, and this is, again, simplifying to fractions or multiplication problems. I want to put these as a complex number in standard form, meaning there should just be one real part and one imaginary part. With this problem, there's not just one real part and one imaginary part. I have a real part here, I have an imaginary part here, I have another imaginary part here, but does it make sense that I should distribute? Let's distribute this I in. And again, it behaves just like a variable. So negative I times 4 is negative 4i. Negative I times negative 8i is positive 8i squared. Wait a second. I know what I squared equals, right? Right? Remember this slide where I said that I squared was -1? This will come up in a lot of problems. The fact that every time you see an I squared, you could just as easily write -1. So that changes my problem to -4i minus 8 because I squared is -1. 8 times -1 is -8. This is in standard form. Look, just one imaginary part, just one real part. That's in standard form. Let's also do the same thing for over here. Now, something that's going to help us is a trick that we've seen before. Remember when I was rationalizing the denominator? Like if I had something like 1 over root 3, I'd multiply by root 3 over root 3. That would give me root 3 over 3, and that was happy because I had the square root off the bottom. We're going to do something similar with i's. I really don't like seeing this I on the bottom of my fraction. As long as I have it down there, I can't get it into standard form because it's on the bottom of the fraction. So how do I cancel the I from the bottom? What happens if I multiply by I on the top and the bottom? On the bottom, let's just worry about that. I have 3i squared. But what's I squared? It's -1. So 3i squared is really -3. Nice. On top, this I would distribute to the -2 and the -5i. So -2 times I is -2i. -5i times I is -5i squared. We know that I squared, again, is -1. I told you it comes up a lot. So -2i plus 5, because I squared is -1. To put this in standard form, I would probably want to distribute this division through. So let's do -2i over -3. That would simplify to 2/3 I. You could also write 2i over 3. Either way works. I'll write 2/3 I because it looks a little more like something times the imaginary number. Also, 5 divided by -3, let's just leave that as -5/3. This is standard form. Look, I have one real part, I have one imaginary part, funsies. All right, that's all I have for you. Imaginary numbers are pretty simple. They work just like variables. All you have to remember is that I squared is -1. The reason imaginary numbers come up is because when I'm solving equations, sometimes I have to take the square root of a negative number, which is not actually allowed. So, as a summary, remember the square root of -1 is I. So if you ever have to take a square root, so for example, x squared equals -4, when we take the square root, we can say, hey, -4, that's the square root of -1 times 4. That is 2 times I, or 2i. And remember that I squared is -1. It comes up a lot in simplification problems, and it helps us to rationalize the denominator when there are i's involved. If I multiply by I on the top and the bottom, that means there will be an I on top and an I squared on the bottom, but I squared is -1, which means now I just have an I on top. Yes. All right, that's all I have for you. Hope you enjoyed the video. Hope you enjoy imaginary numbers. They sound hard, but they're not. You can impress your friends with your knowledge. Good luck.